Hi everyone and welcome to lesson 3 from topic 9. Today we're continuing with our conversation about transformations, and today's transformation we're talking about is a rotation. So you probably already can picture what a rotation is, but we're going to learn about it in this quick minute video, and then we'll do some practice together.
A rotation is a rigid motion that turns a figure about a fixed point called the center of rotation. The angle of rotation is the number of degrees the figure rotates. A positive angle of rotation turns the figure counterclockwise. Suppose the origin is the center of rotation. You can rotate a figure 90 degrees, 180 degrees, 270 degrees, and 360 degrees about a center of rotation.
Here comes your song.
Here's a crazy dance called the rotation groove. All you need to learn is that the figure must turn about a fixed point. That's a rigid motion, see? As simple as can be. Come on and move. Do the rotation groove.
Okay. So that is, those are a bunch of different examples of rotations. So um, there's a lot of terminology in this paragraph right here, so I want to talk about it again. So rotation is a rigid motion. Remember, all of the transformations that we've learned so far, which are translation, reflection, and now rotation, have all been rigid motions. That means that the shape does not change size. It doesn't change anything about the shape other than the position of where it is on the graph. All right, and when you have a rotation, you need to also have a fixed point called the center of rotation. So sometimes that is the origin, sometimes it's another point on the shape, and sometimes it's a random point somewhere else in the coordinate plane, and it's going to rotate around that. So you can kind of picture the universe, how the sun is at the center of the universe, and then the planets rotate around that. Those are rotations. So this point would be the sun, and these would be the planets rotating around it. All the coordinates in the shape would be the planets rotating around the sun. Okay, and then the angle of rotation is how far we rotate it. So whether we rotate it 90 degrees, 180 degrees, or 270 degrees, or 360. Usually they're in increments of 90. I'm not sure if there's examples in our lesson today that are not in angles of 90, but for the most part, they're all in angles of 90. So let's get started with some practice. So we need to identify which one is a rotation. And rotations are really hard to spy when you look at a graph. So the one that stood out to me right away was this one. I think this is a reflection because if you fold this on the X line, you're going to have all these equal spots. So I don't think it's this center one. And then this one to me looks like a slide where B went down 1, 2, 3, 4 units, A went down 1, 2, 3, 4 units. So I think this is a translation, which means by process of elimination, this one is probably the rotation. But how did it rotate? So maybe it rotated around the origin and the triangle slid over here, and then slid over here, or rotated, I guess is a better word than slid. Rotated here, and then rotated here. And if you want to, you don't have to, but if you want to, you can put a piece of, if you have like parchment paper or saran wrap or something, maybe even a Ziploc bag, you can put that up on the screen right here. And then sketch very carefully so you don't draw on your computer screen, but sketch this triangle and then rotate it. Hold your finger or a pencil right here and then slide the bag around. You'll be able to see that it aligns with this shape down here in this quadrant. All right, so this is indeed the rotation. So now in your book, and actually maybe it would be better to just do this one in your book, the rotation with the plastic bag idea. So this one we need to find out which one is a rotation again. So let's start with this one here, and it looks like they're rotating around the origin still for all of these. So if you even take a piece of paper, a white piece of paper, you'll probably be able to see through it. Trace this triangle and then slide it down, or I'm sorry, rotate it down while keeping your pencil at the origin. You're going to be able to see that it does line up with this new blue triangle. Therefore, this first option is is a rotation. All right, so in part two, they're going to show you how you can use a protractor to measure an angle of rotation. So I want you to watch this 30-second video, and then we're going to dive into it a little bit deeper.
You can use a protractor to find an angle of rotation. Suppose you have a point P. You rotate point P about a center of rotation O. You can find the angle of rotation with a protractor. The angle of rotation is 135 degrees.
All right, so let's talk about what we just saw on our screen here. So I'm going to rewind a minute here. First of all, we had point P just by itself. P was the point that we were going to be moving around. Then we decided the way we're going to move it, the fixed point that's not going to move, is point O right here. So in my space example earlier, O would be the sun, P would be the planet rotating around the sun. Okay, and then they did a rotation, so P, it slid doop 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 all the way over to its ending spot. And now it's saying, well, can you tell me how much it rotated? And you can by looking at where P, the original P, started. Let's look where the original P started and where the new P ended up. And then you can look to see, okay, I'm going to measure it. So this tool is called a protractor. If you haven't used one before, you're going to want to look up how to use a protractor because I won't be able to cover it exactly in detail right now. But basically how you use a protractor is you line up the where the two lines meet. So where the angle meets, you're going to line that up in the center of your protractor. There's usually a hole or an indentation. So you line it up right there. And then you make sure that one of the lines of your angle is straight along the zero line. So you'll see right here, there's a zero. And then in this case, do you remember how the animation showed us that the blue dot rotated up and around this way? So that means we need to start with zero being here and then looking to see how this angle opens up to between 130 and 140. So this angle is at 135 degrees. All right, we also know that the other line that it's pointing at is right here at 45. The other angle it's pointing at is 45. But we know that this angle, let me take away the protractor here. We know that this angle can't be 45 degrees because it's bigger than a 90-degree angle. So if that helps you too with which way to read your protractor, because there are both sets of numbers on the protractor, you need to look at the angle that's larger than 90. So you're going to be looking at these inside numbers. All right. So that means this rotation was 135 degrees for the rotation. Oops, I think you have got it. Oh no, we have another example. Cool. Okay, so what is the angle of rotation about the origin that maps A, B, C to A prime, B prime, C prime? So the way you do this, and let me go ahead and grab this picture. I don't know if this is going to work in our workbook or our notepad, but we will try. We're going to do the best we can with this. So we first are looking at the original, the pre-image, which is the black triangle, and then the image, which is the blue triangle. And we need to draw lines. So it told us it was rotated about the origin. So we need to draw lines from the original point to the origin. And then from the origin to the new point right here. So just by looking at it, this looks like this, because this black line, the line I just drew, this is the angle that we're going to be measuring. But this looks like it probably is a 90-degree rotation. But we're going to have to look on our, with our protractor here. So, ooh, can we slide you over? Good. Okay, so we're going to line up the protractor. This is very hard without being able to draw the lines on here. So we're lining up the protractor so that this black line kind of points towards A, and this one points right towards B. We don't need to line that up, but this looks like it's either 90 or maybe 85. If you had your own paper, you'd be able to check this a lot closer. Yep, okay, so it is a 90-degree rotation. So you can see it better here in their image. So this is the red line is the origin to A. This red line is the origin to A prime. And then when you measure this angle, it is exactly 90 degrees. So it's pretty hard to do on a computer, but when you have your paper and a protractor with you, you'll be great. Okay, so what's the angle of rotation about the origin that maps JKO to J prime, K prime, O prime? Let's do this one together just because these are a little funny to think about. And then we'll get into our last example and our close and check, and then we'll be done with rotations. Okay, so we need to look at one of the coordinates. It doesn't matter which one, but we can look at J, and it tells us that it's being mapped around the origin. So our origin is right here, 0.00. Make that a different color here. And now let's look at point J. So we're going to draw a line from the origin to J. And then we need to draw a line from the origin to the new J. And if you notice, I drew a straight line. Well, what is a straight line? That's not straight, but a straight line has 180 degrees. So we know that this rotation was 180 degrees. All right, here's our last section of the day. It says triangle A prime, B prime, C prime is the image of triangle ABC after a 270-degree rotation about the origin. So here's the origin, here's the original triangle. It rotated this way all the way to this new triangle. It says you can use arrow notation to show how each vertex, each point of the triangle, maps to its image, the new triangle, after the rotation. So this is how we can annotate that there was a rotation that happened. So you would say A at -4, 6 rotated to this arrow, A prime at 6, 4. Okay, and then here's B. B was -2, 1, and it rotated to B prime, 1, 2. C was -1, 4. It rotated to 4, 1. All right, and if you want some bonus points here, see what you notice about all of these numbers. See if you can see a pattern here in these numbers. If you notice, the order of the number switches. So the 1 is in the X spot and the Y is 4. Here, X is 4 and Y is 1. So they switch spots, and then this was a negative, and it's now a positive. So there's some rules that we're, actually I'm not sure if we're getting into them here. Nope, we're not getting into them, but there's some rules you'll learn later on in geometry that tell you how you can, without drawing the rotation, how you can just use math to figure out what coordinates go where. So rectangle ABCD has these coordinates. Drag the blue rectangle to show the image of a rotation of 90 degrees about the origin. So here, let's go ahead and use B. Here's the origin, so 90 degrees would be right here. B needs to be up here. So we're going to rotate B up to here, just like about that. And then we would label the vertices, the vertices. Okay, so that's what it looks like for a rotation. Yours are going to be, point P has the coordinate 3, 0. If you rotate it about the origin, what are the new coordinates? I'm going to pull up the correct answer now so you can take a look, but I do want you to try it. We're just running a little short on time here. So 0, -3. Now go ahead and do your closing check and I'll pull up the answer. Here's the answers. Have a great day, everyone.